Why, gee golly, Billy, I sure do love math.
I sure do too, you know? I think it's a great subject. What about you, Pete?
I am so good at algebra that I could replace your ex and you would not even know why.
No way. No way. You would never. You would never. I understand math very, very well. You know, I don't understand how people can't understand math very well because... Oh no! Oh!
Boy! Boy!
Oh no!
That's pretty hard. Oh, I broke your glass. I'm sorry, but you nerds are coming with me. You nerds, man. Come on, get up. Stop doing
Let me
that.
finish my math.
No, you're a nerd. All right, get up and go to my little cave over there. All right, you can't break. Get up.
Can I take my calculator?
Yeah, sure. Keep on walking, boys. Get over there. Get on the wall. Get on the wall, boy. Yeah. You damn math people. Yeah, get on your knees. All right.
Who even are you?
What do you want from us?
Wait, I still don't even know who you are.
Right.
I am BESIDJU, bruh. Okay? And I want you to teach me calculus. You feel me, bruh?
You mean calculus?
Yes. Calculus. So who here knows geometric sequences?
Yeah, that's like the easiest part, duh.
Okay, teach me.
Okay.
Okay, so I'm going to be teaching you about geometric sequences. So first equation you want to know is just the regular equation, not the sum equation, how to represent a series. It's a1 times the rate to the n minus 1 power equals your nth term, or whatever term you want. The second equation you want is the sum, which would add up all terms that you had up to the nth power. And so that is a1 times 1 minus r to the nth power divided by a1 divided by 1 minus r equals the sum. And so let's start off with a thing about genetic info. So let's just say there are 3 people who have this trait, and so they always pass it down. And they always have 2 children in each of the generations. And so that would be represented as the first value is 3, representing the 3 people. The rate is 2 because their kids have 2 kids and their kids have 2 kids and so on. And the nth term is how many generations. Let's just say there's 21 generations that go on between the first ones and the last ones. This can be represented as 3 times 2 to the 21th power minus 1 equals an, which simplifies to this, simplifies all the way down to here, all the way to here. So there's about 3 million people by the 21th generation that have that trait, which is a pretty big number, but when you think about it, 20 generations is a lot. So let's do something a little more concrete. Let's just say you tell a secret to 3 people, and they tell a secret to 3 people also, that same secret. How many people by the 3rd round know about this secret? And so this can be represented by 1 times 3 to the 3rd power minus 1, which equals 3 to the 2nd power, which equals 9. So 9 people know that secret. So by the 3rd term, or are told this on the 3rd term. So let's see how many people have been told so far about that secret. So this can be represented using the sum formula. So the first one, or the first A is 1, because you are the first one who knew the secret. It can be represented as 1 times 1 minus 3 to the 3rd power over 1 minus 3. And so it simplifies down to 1 minus 23 over minus 2, which simplifies down to negative 26 divided by negative 2, which is 13 people. And that is geometric formulas.
Wow, okay, that's a lot. Who here knows how to do arithmetic sequences?
Me? Who doesn't know how to do arithmetic series?
Well then teach me.
Let's go.
No, you have to go.
Alright, first let's go over what an arithmetic sequence is. So we have our first term, which is a of 1. And for an arithmetic sequence, we add, for the next term, we add d. So d is the common difference. And yeah, so the second term is a plus d. The third term will be a plus 2d. Till we get to our nth term, which is the last term. And if you notice, so for our first term, right, we add d 0 times. For our second one, we added 1 time. For the third one, we added it 2 times, and so on and so forth. So pretty much what that means is, like, whatever index we are on, we multiply d 1 less many times. And that's how we get the formula a of 1 plus n, which is a number of terms, minus 1 times d, and d is the difference. So that is the arithmetic sequence formula. Now let's go to arithmetic series. Arithmetic series is the sum of an arithmetic sequence, and the formula for that is n times a of 1 plus a of n over 2. And a of 1 is the first term, a of n is the last term. You add those two, divided by 2, and times it by the number of terms there are. And this is what you do to, this is the arithmetic series formula. Let's start with our first practice problem. Let's just say the first number in a series is negative 53. And the common difference is 6. We need to find the sum of the first 880 terms. So how would we do this? We would mix both the formulas and to find the solution to this problem. So the first step is to just write it out, to like see where we are. So our first term is negative 53. And then since the d is 6, we do add 6 to it. So we'll get negative 47 plus negative 41 and so on. And now we have to find the last term of the sequence. And we do that by adding the first term. We do that by adding the first term. So since we're looking for the first 880, we put in 879 because of the n minus 1 formula. And then we times that by 6 because 6 is the difference. And once we calculate all this out, we get 5,221. And this is the sum of the series. Next, after we have the number, it's really simple. All we do is just plug in numbers. We use the series formula, so we get negative 53 plus 5,221 over 2 times n, which is 880. So the first term plus the last term divided by 2 times the number we're looking for, which is 880. And once we calculate this out, we get 2,273,920. So let's do our second problem. Let's find the sum of this sequence. Let's find the sum of this. And since there's a dot dot dot, we don't know how many terms there are. So first, we need to find the number of terms. And we do that by getting the last term, which is 605, and minusing it by the first term, which is 8. And then if, as you see, the d is 8, the d is 3 because we're adding 3 each time. So we do this over 3, and we get that to 199. And that means we have 199 terms in this sequence. Second is really simple. All we do is just plug in the formula again. So we get 8 plus 605, which is our first term and last term, divided by 2 to get the average, times the number of terms we have, which is 200. And the reason it's not 199 is because we forgot to add the first term itself. We need to add 1 every time. So after we do this, we get 61,300, and that's our answer. Alright, now let's talk about the Fibonacci sequence. And the Fibonacci sequence is a series of numbers in which each number is the sum of the 2 preceding numbers. And this is how we do it. So we have 1 and then 1, right? So we add the last 2 terms. So we get 2. To get the next term, we do the last 2 terms. So we get 2 plus 1, 3. And then the next one will be 3 plus 2, 5, and so on and so forth. And that's a Fibonacci sequence, and it's very important in math.
So, I'm guessing you must be the one that knows infinite series.
Oh yeah, I love infinite series. It's my favorite part of math.
Teach me.
Infinite sum is kind of like the geometric sum that I taught you in Devin's part, but it's also it can sum up a finite series that's converging. And what is a converging series? A converging series is a series of numbers in which the last number approaches 0, and so it can be represented as like a square or something. So let's just say this square is like 1 unit, and so the first term is a half, second term is a quarter. Alright, to find the rate of which it drops, or like rate in which it multiplies by, you can do a2 divided by a1, which is 1/4 divided by 1/2, where you get 1/2 from that. And so you plug this into the equation, you get 1/2 minus 1/2 divided by 1 minus 1/2, which is 1/2 over 1/2, which is 1. So this whole thing is 1. And don't get hung up on this part, because that's just the series dividing up a finite amount of something infinitely. It's not that it's always continuing or something. Alright, let's go on to the second question. A ball is dropped from 1 meter. With each bounce, the height is 3/4 of the previous bounce. Find the sum of all the maximum heights. So the first variable, a1, is equal to 1 meter, right here. And the rate is given, which is 3/4. So you plug this into the equation, you get 1 over 1 minus 3/4, which is 1 over 4th, which is, if you were to flip it over to the equation so it actually makes sense, and you can like multiply this, you get 4. So all the maximum heights of the infinite bounces equals 4 meters, and that is infinite series.
Now, one more. Who here knows sigma notation?
I think they got it. I'm not really familiar with this.
They don't know sigma notation. You don't know sigma notation.
Someone teach him!
He is dead. Dead! Now, boy. So, Devin, do you know?
I am trying to blah 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 blah. I am trying to blah 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 blah
Please, this guy.
blah blah blah.
I don't understand him.
Blah 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 blah. I am trying to blah.
All right. Last boy, Billy. So, Billy, I'm gonna take my sunglasses off for you. By chance. Oh, okay. Do you happen to know sigma notation?
I I don't. I can teach you other math. Anything else. Anything.
Sigma notation. Teach me that.
I don't. I can teach you anything else. I can teach you anything else. Please.
No! Man, I felt like Caesar from Planet of the Apes there. But, so that's what happens when you don't learn Sigma notation. You get it through your head. You know, it being a bullet. So, I'm gonna teach you Sigma notation. Thumbs up, bro. Alright, my dudes. So today I'm gonna teach you about Sigma notation. So first, this is what Sigma notation looks like. It's like those Greek symbols you see in the frat parties. Alright, I can't draw, but let's just get to the rest of it. So this stuff, what do these mean? Well, I don't know. Let me look in the textbook. So this means the maximum value of n, alright? This is a starting value of n. Usually the standard is 1, so let's just keep it at that. And this an is the expression of the general term. So that's the basic information you have right here. So let's do a really simple problem. So let's do that problem I was talking about. So let's say this is a problem the problem you get. All right, n equals 1. Ooh, you get the 5 right there. And here is your equation, right? Oh crap, Sandy. What am I supposed to do? I want to find the first term. Well, it's simple. You just plug in 1. All right, a1. What do you get? I did the math in my head. You get 1. Look at that. Now you'll find the next one. A2. You put 2 in there. What do you get? Whoa, you get 3. Oh, we're getting somewhere. Look at that. Look at that. You got a comma now. You know, put in the third term. How about that? Look at this. You got 5. So I kept going in my head, and look what we have. We have 3. No, we have 5. Look at that. 5 terms, just like it says. There you go, my dudes. Math.